The vastness and infinity of space has amazed and puzzled humanity for a long time. There has always been this nagging concern about whether we are alone in the universe, and what mysteries might lie beyond Earth. Now NASA scientists have uncovered an astonishing find from a single, enormous source in deep space. Millions of radio messages are being delivered to Earth. That it could be? Do they have a natural explanation, or is there another explanation? Due to the unprecedented scale and coherence of the signals, scientists have more questions than answers. Fast radio bursts may seem like an uninteresting event to some, but they have fascinated astronomers, physicists, and space enthusiasts. Their cryptic character adds to their appeal because there is so much about them that is still unknown. Imagine the excitement among scientists when they first noticed multiple fast radio burst signals in a short period of time, and kept doing so. Who or what is trying to get our attention, and what might they be looking for from us? That is what we are left to ask ourselves. Radio fast bursts are intense radio emissions that last a few milliseconds. They are known as Lorimer bursts after Duncan Lorimer, who discovered them in 2007. When telescopes record a fast radio burst, scientists pay attention to scattering, which is how the signal spreads out on arrival at Earth due to plasma in space. Radio waves of lower frequencies slow down and have more influence than those of higher frequencies. Scientists use scattering to determine the distance from the source of fast radio bursts. Greater dispersion indicates greater separation from the source. The first fast radio burst was discovered near the Small Magellanic Cloud and resembled the massive radio pulses of pulsars. Although precise measurements of the signal flow were not possible due to the limitations of the observing equipment, the researchers believe that it is possible to detect several hundred bursts per day. Initially, the fast radio burst was thought to be a unique event because it was only observed in 3 of the 13 receiver beams. However, interest in the subject was renewed when another burst with a dispersion similar to that of the Lorimer burst was discovered. Fast radio bursts received their official designation after 4 additional Lorimer bursts were identified in 2013. These bursts had considerably greater dispersion and were discovered by surveys conducted with a high temporal resolution radio telescope. The brightest burst showed a broadening of the scattering that suggests the presence of alien radio emission sources. The first fast radio bursts found at another observatory were announced in 2014, but their origin has yet to be determined and scientists continue to investigate. Technological advances and new study methodologies help us better understand the enigmatic fast radio bursts and their causes. In 2019, astronomers made a startling discovery. Source 121102 broke the previous record by producing 1,652 flashes in just 47 days, opening up new research possibilities. However, the scientists failed to find any pattern or periodicity in the bursts, which left them baffled. Most fast radio bursts only flash once and are gone, making them difficult to predict and detect. However, the 121,102 source has proven to be one of the most active, and has been traced to a dwarf galaxy located 3 billion light-years away. It is a strange object that raises more questions. The 121102 source of fast radio bursts is quite irregular, with a pattern of activity after 90 days followed by 67 days of silence. The 500-meter aperture radiospherical telescope, FAST, has been instrumental in observing these bursts, even during its testing phase. In just 47 days, an impressive 59.5 hours of data was collected, the most ever recorded. The researchers categorized the gusts based on their energy and found that the weaker ones were more unpredictable despite their irregularity. Despite the challenges, scientists continue to search for fast radio bursts and have discovered that they can generate an enormous amount of power in an instant. Recently, the FAST telescope also discovered a new burst, 190520, distinguished by its repetitive frequency, emitting 75 bursts in 6 months. The researchers used the Very Large Array Telescope in New Mexico to further study these bursts. The scientists managed to identify the origin of the fast radio burst signals, which come from a dwarf galaxy located 3 billion light-years away. They found a weak radio signal in the same area, which is surprising since only one other source is known with this persistent feature. However, there was a discrepancy in the calculated distance, which was 10 times greater than the actual distance based on the dispersion of the fast radio bursts. Although only 19 of the more than 800 reported signals have been detected, astronomers rely on scattering to calculate the distances of the remaining sources. These fast radio bursts continue to raise many questions, and scientists are doing research to better understand their nature. As more signals are discovered and their characteristics explored, new questions are raised about their origin and relationship to persistent radio signals. Research continues using telescopes around the world to unravel the mystery of these bursts and expand our knowledge about them. Although progress has been made in recent years, there is still much to discover and understand about these bursts of radio energy. Taking advantage of technology and global scientific collaboration, we hope to learn more about these unusual things and better understand our universe. There is a burst of radio waves traveling through space towards a distant star cluster, transmitted from an ancient radio telescope on a blue planet orbiting a dim star. This message, known as the Arecibo message, contains information about humanity and is encoded in binary. Although the answer would take 44,000 years to arrive due to distance, we are still trying to make contact with the unknown despite the challenges of space. A group of scientists from NASA's Jet Propulsion Laboratory have joined the effort by developing a new message called the Lighthouse in the Galaxy. The field of extraterrestrial intelligence, METI, involves designing and sending communications into space, and METI differs from SETI in its more daring and curious approach. This topic is controversial and divides the SETI community. The consequences of contact with extraterrestrials are debated. METI supporters believe it would be beneficial, while others are cautious due to uncertainties about aliens and possible implications for our civilizations. There are no immediate plans to broadcast the Lighthouse in the Galaxy into space, but it is intended to improve our ability to create interstellar messages. The goal is to introduce ourselves as explorers interested in science and information. However, our television broadcasts would give a different image of us. Like Voyager's Golden Record, it was decided to show the best of us and avoid sending a hostile message to the universe. The Lighthouse in the Galaxy seeks to establish common ground with possible extraterrestrial beings by using universal scientific concepts. Start with ideas like the quantum foundations of hydrogen atoms to build a foundation of understanding. He then explores topics like biology and human DNA. In addition, it includes a map to highlight additional information. A modified illustration of a nude man and woman, originally found on Pioneer space probes, is also featured in the message. This illustration has been adapted over the years to remove any negative connotations or gender imbalance. However, it is important to note that aliens might not understand the human greeting gesture depicted in the image, as it is a cultural practice specific to our species. The Lighthouse in the Galaxy and the Arecibo message are encoded in binary code, which is considered the most understandable mathematical language for possible alien life forms. The binary uses simple terms of yes or no, true or false, and 0 or 1, which any intelligent creature or computer could understand. Broadcasting into space has generated debate, but some scientists don't see it as a negative. It could lead us to reconsider our role in the universe, our future possibilities, and what we could learn from extraterrestrial civilizations. Since we are young compared to other species, it is likely that aliens are much older than we are. SETI seeks to connect with higher beings that could be thousands, or even billions of years older. Carl Sagan argued that aliens could teach us how to prevent nuclear war, which he used to convince Democratic Senator William Proxmire to endorse SETI. Some question if this really represents how Western civilization works, or if it is just a fairy tale. Although there are kind and generous people, governments rarely offer help without conditions. Should we be indebted to an alien race? Although sending interplanetary messages is an interesting idea, they are unlikely to be noticed by aliens. However, by deciding what we want to say about ourselves and who has the right to say it, we can learn about our society. We are in the early stages of designing interstellar messages, and there will be mistakes. We need an inclusive global dialogue, not just with Western SETI specialists, so that our communications are representative. Also, time and distance protect us. We won't be exchanging messages with the aliens anytime soon. This will happen in the distant future, in future generations. Let's hope they're ready.